Hello everyone, my name is Sudhang Shankar. I am a software engineer and master student in computational social science. This is my submission for the ArangoDB GraphRag and CuGraph Hackathon. My project is focused on studying the network of top physics researchers and their papers. This domain falls under the umbrella of science, which is a field that combines sociology and data science. I basically got this data from another data source, which was the list of top 1,000 most cited physics papers over the last few decades. And from this I created this network which you see over here. So as you can recognize, this is the ArangoDB web interface. And you can see there are two types of nodes, yellow nodes and blue nodes. So the yellow nodes represent authors, in this case Paul McEwen, and the blue nodes represent papers that have been written by this author. So this edge means that this author wrote this paper. And the paper contains useful information like the title and abstract. And on top of that, an author may be connected to another author as well in a co-author relationship. So basically this means that these two authors wrote some paper together. That paper may not be visible in this view, but that is how the relationship was created. So with this network of co-authors, we are already able to see who are the most influential authors within this co-authorship network based on PageRank. So these are the top 10 most influential authors by PageRank within the co-authorship network. It means that they wrote a lot of papers with other authors who also wrote highly cited papers. Some of them may be famous or recognizable. Then I first show a small search dashboard. This leverages the full text search capabilities of ArangoDB on this graph database. We can see that this is a large subgraph of people who have studied, who have written papers about mechanics. You can see a lot of people here all over the world. Institutions are also quite diverse, and the field has been there for quite some time with lots of prominent publications. Whereas if we compare it to another topic like say Monte Carlo, then we see that it's a sparser data subgraph, mostly in the West, mostly famous Western universities with not so much activity, only starting from 1971. And this dashboard is leveraging full text search and AQL from ArangoDB. And the last thing I want to show in the live demo is this chatbot. So I can ask questions like, what papers has Stephen Hawking written? And this leverages GraphRag with LangChain to answer questions factually about what we're asking based on the graph database and the graph data that we just showed. So you see we have these 5 answers that it got. It does a good job of even summarizing them and even summarizing his overall career, so that's great. So now that I have this, I want to show how I created this data set in the first place. Basically I had this data set of top 1,000 most cited physics papers. It had various things, except it didn't have a title, it only had the abstract. So I created the title using GPT 3.5. And then I merged this dataset with a dataset of affiliations. So basically who the authors are, where they're from, where they are working. And with these two together, I created a bipartite graph with network X, and then I exported it, and this file is available on my GitHub. So with this data in place, I think I'll just ignore this. This data in place, I'm able to have my submission notebook. I'll skip this beginning part, but then just want to show that this is some exploratory visualization on the loaded dataset. So this is the mathematician Terence Tao, and we see that he wrote this paper along with these two researchers to get a rough idea of what the data is like. So one of the things before I can persist it into ArangoDB that I found was that I had to make sure that my dataset was clean. There were no nulls where there shouldn't have been. Unlike Gephi and other tools, ArangoDB is more strict. Therefore, I had to do this cleanup. Then apart from that, one of the choices I made was to have a separate author collection and a paper collection. So for the two different types of nodes, I had different collections. I did not put everything into a single collection and differentiate them by some property, which is what we do in Network X. My reasoning for this is I believe this is how it's supposed to be done in ArangoDB with heterogeneous nodes. And I found this Colab notebook on GitHub, which shows how you can create your own custom controller to be able to achieve this effect. And yes, after showing the ArangoDB system how to differentiate between nodes from my Network X graph, I was able to ingest the data. And on top of this, I also created a Arango search view to be able to do full text search on my abstracts. This is what was used in the demo that I showed. And I also added some stemming analyzer and nice things like that. I did something similar to be able to search for authors as well. I never showed that, but it's available. And then I can get to the building the agentic app. So the biggest change that I had to do was I had to show a lot of examples to the AQL creator. Not too many, but I had to show a few examples how to properly query my dataset. And one of the interesting things was that had I done it the other way, had I not created this bipartite graph with different collections, I believe I would have to give way more examples. So that was the advantage. Then these are some examples, and then these are the tools that I use for creating this dashboard. So it's basically, some of them are normal AQL, some of them are CuGraph or Network X queries, and some of them are hybrid. And ultimately I show them using Gradio, using the Plotly library so that they're interactive. So this is it for what I have to submit. It was a great learning experience. I thoroughly enjoyed it. I also believe that it is necessary for people in academia to start using such tools in order to do their research better. So I will definitely be suggesting that people in academia start using graph databases and GPUs for their research. That's it from me. Thank you so much for your attention, and I look forward to looking at the other submissions. Thank you very much.